Hello, I'm Landon Schlungen, and today we are going to be working on the Sudoku solver, part of the quality assurance projects on FreeCodeCamp. So let's go into that. It has to be functionally similar to this project right here, where we can put in a coordinate and then it will check if it can go there. So if I put in the coordinate A1, which is this first spot right here, and I say that it can be 2, and I check it, then it says conflict region because there's a 2 here. If I put in 3, check placement, there's a 3 here, so it can't go there either. But if I put in, say, a 7, then it says valid is true, and it can go there. And then we can also solve the whole thing right away by clicking the solve button, and then it solves the whole Sudoku puzzle right away. If there's a G or some other random character in here, and I try and solve it, then it says error invalid characters in puzzle. If there is an extra dot in here, then it will say expected puzzle to be 81 characters long. So it has to be very particular with how these puzzles are formed. Also, if it can't get solved, so if I put a 6 in here and I try and solve it, then it says puzzle cannot be solved because there's 2 6s in this region, and it can't do that. So this is what we're going to be working on. I'm going to be cloning the GitHub repo and completing it locally. So let's go into that. Grab the code like this, copy the HTTPS part, and then open up Visual Studio Code as my editor of choice. And here we go. I'm in my FreeCodeCamp Projects 2 folder, like I always am for these videos. And all we have to do is do git clone and then paste in that link and clone it in, and it should be the boilerplate project Sudoku solver. I'm just going to rename it quick. I'm just going to call it Sudoku solver. So there we go. I have my Sudoku solver. I'm going to check the package JSON. We have all of these in here, and it doesn't look like we're going to connect to the database for this project. I don't know why we would have to. So that's cool. We don't have to install any of that, and they already have nodemon installed. And then also npm run start runs nodemon server.js, so we don't have to worry about that. But we still have to install all of our dependencies. So we want to cd into it first of all, into our Sudoku solver, and then do npm install. And that should install all of these dependencies that we need. So there we go, I installed them all, and then we can also just run it. So npm run start, and it's listening on port 3000. So let's open that up, localhost 3000, and here's our project. If I hit solve, it doesn't do anything. If I do anything with the coordinate and value and check it, it won't do anything either. And that's what we have to make. I'm also just going to open this up in the Sudoku solver folders quick here. So, all right, and most of the logic goes in this Sudoku solver class. So when we call solve, it will solve the puzzle. If I check row placement, it will check that that number can go in that row. And it connects to this inside of the routes folder, the api.js file. This is our 2 routes that we need to actually do stuff in. And I think I'm first going to be working on the solve part, because I think the solve part is, I don't know, just because I want to do the solve part first, I guess. And the way we do this is by, I'm just going to copy a part over. We get the puzzle out of the rec.body, out of this route, and then we say if there's no puzzle, then there's required field missing. If the puzzle.length is not 81, we expect it to be 81 characters long. If there's an invalid character inside of the puzzle, so there's not a 0 through 9 or a dot, so like if there's a letter in there, then it says invalid characters in puzzle, and then we try and solve it. So we do solver.solve and we pass in the puzzle to it. If the solver cannot solve the puzzle, then it says puzzle cannot be solved. Otherwise, it gives us the solution and the solved string. So yeah, pretty simple there. The more complicated part is actually getting it to solve, and there's a couple algorithms to do this, but I just kind of settled on one that I could look up really quick, and it is on a website. So I'm going to look up Sudoku backtracking algorithm, and it's right here. This is Backtracking 7, Geeks for Geeks. This is where I went to get the algorithm that I needed. I mean, if I wanted to come up with this backtracking algorithm on my own, it probably would have taken me a lot longer. But it's much easier to just copy and paste someone else's code, and it's much more efficient too. So, and I know Java a little bit, so I'm going to copy the Java code, and I basically need this solve Sudoku function. This is what they look like in Java, and I also need this isSafe function right here as well. So I'm going to copy both of these. First the solve Sudoku one, if I can. I'm going to copy that, and I'm going to put it inside of my controller Sudoku solver class, and I'm just going to put it right above this solve part. And obviously there's going to be errors right away because this is in Java and not JavaScript, and we just have to change it so that it will work. First of all, get rid of the static boolean, get rid of the two double arrays here, get rid of the ints. This will work here as long as we have n, but n is 9, so I might as well just change that to 9. At least I'm pretty sure n is 9. Static int n equals 9, so yeah, n equals 9. I also need the isSafe function, which is right here. This checks whether it will be legal to put in a cell or not. So copy that over. I'll put it underneath the solve Sudoku function. And again, don't worry about the errors. Just make it work. So get rid of that, get rid of the ints, get rid of the static boolean. Int x, I can't find that, looks like. And that is because, oh, that's because it has to be let x. That's why. We have to do let x so that it becomes a variable inside of this for loop. We have to do let x here, and we have to do let start row, and then change all these ints to lets. And there we go, that should work now. Inside of here, change this int to a let, and there we go, we don't have any errors anymore, and I should save it, and it formats it for me. Also, I could get rid of a bunch of these comments just to kind of scrunch it down. I think I'm going to do that quick. There we go, we have our solve Sudoku algorithm, and we have our isSafe algorithm. The solve Sudoku algorithm uses the isSafe algorithm to solve the Sudoku. And basically how this backtrack algorithm works is it tries a number. If it doesn't work, then it goes on to the next number. If that works, then it moves on, and it will try all the numbers there if they work, and then it will make its way through solving each part. If a part doesn't work, then it'll go back however many it needs to so that it does work, and then it will make its way through the puzzle. And I basically just copy and pasted some code from Geeks for Geeks to make that happen. So now that we have that, we will also see that the puzzle string is in this format, and I need it to be in a grid for it to work. So that's why I made another function. And this other function I name transform. So I'm just going to put it under isSafe, and here it is. We transform this string into a double array as a grid like this, because that's the format that my puzzle solving algorithm needs. It needs it as a grid, as a double array for it to work. So here I just grab a grid, put in a bunch of zeros, and I have a for loop here that goes through all 81 characters inside the puzzle string, and it will kind of just make its way down the grid, and it will insert into that spot the character in the puzzle string. If it's a dot, then it will insert a 0. Otherwise, it will insert the number, and then it will return the grid at the end. So then when we solve using this function, we first have to get the grid. So we'll do let grid equal this dot transform our puzzle string, and then we have to solve it. So we'll do let solved equal this dot solve Sudoku, and we'll pass in the grid, and we'll pass in the row and column that it starts at, which is 0, 0. And then we have to transform it back into a string. And this one is really easy. To transform it back, all we have to do is do grid.flat.join, and it will just flatten it out and turn it into a string. And we don't have to worry about any dots because there shouldn't be any dots inside of the grid. They should all be numbers, and there should be no zeros in the solved Sudoku, so it should work there. And then we say if it can't be solved, so if not solved, then return false. Otherwise we can do let our solved string equal this dot transform back, and pass in the solved grid, and then return the solved string at the end, and we should be good to go with that. I'm also going to console log it, CLO solved string. I'm going to save it, and I'm going to try it out. First we have to connect it up to our API route, which I guess we already did when I did this. Up top here we do new Sudoku solver, and they import it for us, so then we can just do solver.solve, and we solve our puzzle. So let's try this out. If I go into our localhost 3000 and I hit solve, doesn't look like it's working. We get an error here. Let's see what it is. IsSafe is not defined. Oh, that's because I have to do this .isSafe. So inside of our solve Sudoku, we use isSafe, but I have to do this .isSafe for it to work. And I might have to do that somewhere else, like return this .solve Sudoku. Probably have to do that. And I think it will work now. So let's save that and try it out again. Solve, and nope. Not yet. Solve Sudoku is not defined. Oh, I have to do it right here as well. This dot solve Sudoku. Forgot about that. And now let's try it. Solve, still not working. Grid.flat is not a function. Really. I'm gonna try console logging solved and see what that gives us. Solve. Solved is true. Oh, I know why. Inside of our solve Sudoku, you see we return true as our base case, but we want to actually return the grid. So I'm just going to do return grid for these trues, and then it should work. So save that. We still want to return false if it can't solve it, so or where's the false? Yeah, return false if it can't solve it. So that's fine there. But yeah, just make sure to return the grid and not just true. And now let's try it out. Solve. And there we go. It solved the whole Sudoku for us. Pretty cool, pretty cool. And it returned the solve string in my console log. So that's cool. I can get rid of those now that I know it works. And yeah, so now our solved function works. Next thing we have to do is we have to make sure these coordinates and value thing works. Because right now it doesn't. If I refresh this, it'll go back to normal. So yeah, let's work on this coordinate and values thing. That's inside of our api.js file. Inside of our api/check, so that's where it goes to. We can get our stuff out of rec.body. We get the puzzle out of there. We get the coordinate and we get the value. The coordinate is in the format of A1 or A2 all the way down to F or G or I or something, all the way down to I, because there's 9 of them. So A, B, C, D, E, F, G, H, I, and then a number 1 through 9 after that. The value is just a number 1 through 9. So we have to do a couple checks here to make sure those are valid inputs. We actually have to do a lot of checks here. First of all, we have to check if there's no puzzle or coordinate or value, then required fields are missing. Otherwise, we get our row by splitting our coordinate at the first one to get the letter, and then the column is the number, which is the second one. And then we say if the coordinate.length is not 2, or the first one, so the row, is not A through I, or if the second one, so column, is not 1 through 9, it also can't be 0. So if it's not 1 through 9, then invalid coordinate, error invalid coordinate. And then we check if our value isn't 1 through 9, and it's an invalid value. Then we check if our puzzle length is not 81 characters. We expect it to be 81 characters. And then we check if there's an invalid character inside the puzzle by doing this regular expression test of 0 through 9 and dot. And then, yeah. So those are the checks we had to do. Next thing we have to do is we have to check the rows and columns and stuff. And that is done like this. We check our valid column placement, check our valid region placement and row placement, and we pass in all of our information we need, our puzzle, row, column, and value, and we have this empty array of conflicts. If all three pass, then the valid is true. Otherwise, if there's not a valid row, then we push on the word row onto our conflicts array. If it's not a valid column, we push on column. If it's not a valid region, we push on region, and then we respond with valid false, and we respond with our conflicts that we have, that we pushed on. So if there's more than one conflict, it will know that. Now we have to actually make these functions work. And this part I didn't really copy off of anywhere. I just kind of worked it through. And that's in our Sudoku solver class up at top. We have this check row placement, check column placement, and check region placement. First of all, let's work on the check row placement. So our puzzle string is that string of characters of dots and numbers. And I want to first change it into a grid to make it easier to work with. So we'll do let grid equal this.transform, and we'll pass in our puzzle string. Also, our row is a letter right now, and I don't really want it to be a letter. I would rather have it be a number of the row that it's in. So I'm going to also make a function to handle that, to change the letter into a number. And I basically just use a switch case statement for this. We do letter to number, we pass in the row, we make it uppercase just to standardize it, and then we return the number that it corresponds to. So A is 1, B is 2, C is 3, and so on. Default, return none. Shouldn't ever get to there because we checked beforehand. And then I can just do row equals this dot letter to number, and we pass in the row. So there we go, now row is a number, and this is how we check that the row is worthy. We say if grid at that index 0, 0, or at the index that we say, the coordinate. If that's not 0, then return false. So basically if there's a number already there, then return false. Otherwise, we go into this for loop and we check at every spot in that row. So we go to the row that we specified, and then we check every number inside that row. If that equals the value that we put in, then we return false. So basically what this is doing is, say we put the number 5 in here. First, we check that it's an empty cell, which it is, and we have 5 in here. Then it will check if any of these numbers equal 5, and right here, this one equals 5, so then it will return false. If this was 4, then it would return true. But since it's 5 and it's the same as the number that we tried to put in here, then it will return false. And when it returns false, then the conflicts array will get the conflicts pushed onto it of row. So that's how we know that. And we kind of want to do the same things for the other ones as well. Check column placement. This one's pretty easy as well. The check region placement is a little bit more complicated. So check column placement. We do the first two things as the other one. We change the row to a number, and we change it to a grid, and we make sure that there's a spot open inside that spot, except this one's a little bit different, and we just change the I and the column minus I. That's the only thing that we change. Instead of row minus I, we do I column minus I. Next up, the check region placement. Again, we do the first two things. I could probably just change this into its own function, but whatever, too late for that. Here I kind of copied some of the code from the isSafe function, and I did start row and start column, row minus row modulus 3, column minus column modulus 3, and this will get the region that we need. And we do a double for loop to check that region, and we say that if grid I plus the start row, j plus the start column equals the value, then return false. Otherwise, we return true at the end. So that's how we check the region. Not too bad. I need to change the column here to be call, like that, and now it should work. There we go. Let's save that and let's try it out. We're gonna check A4, or let's check A3 first and try and place a 1. Obviously it can't go there because there's a 9 here already. So it says conflict row column region. Let's try A4, which would be this spot right here. And I'm gonna try and place a 3 in there. Check placement, valid true, because there's no 3 here, there's no 3 here, and there's no 3 inside the box. If I do a 4, I also did 13, not 3. Whoops. Check placement, actually 3, there's a 3 in this column. Whoops-a-daisies. Let's try a 4 this time. Check placement, there, it's in the column and it's in the region. If I do a 7 and check it, there's a 7 in the column, which is true. Let's try a 6, which should work. Check placement, valid is true, because there's no 6s in the column, region, or row. So there we go. That should work for most of the tests on FreeCodeCamp. So let's try copying this localhost 3000 into the Sudoku solver project. And let's paste in the solution link and try it out. And you see that all of them pass, except for the last two, which is the unit tests. And the unit tests obviously are really boring, but I'll kind of go through them anyways, just to show you. And basically we need to do unit tests that handle these tests here. So I'll go into mine right now. And inside of our test folder, we have these unit tests, and they don't really do much for us. We have to do everything ourselves. So I'm just gonna copy what I have. And here I just put in a valid puzzle. And the first test, we handle a valid puzzle string of 81 characters. And I just say assert.equal solver.solve valid puzzle, and then the complete puzzle, which is right here. And then I test a puzzle with invalid characters. So here I put a G in here, and when I solve it, it should return false. Here I added some characters, made sure that it is false returned when it's not 81 characters in length. Here I handle valid row placement. So A2, which would be right here, make sure that a 9 can go there, which is true. Invalid row placement, 1 can't go there because there's a 1 here. So that should be false on the row placement. And then we check column placements, and then we check region placements, and then we check that a valid puzzle string will pass the solver. So that one is kind of a duplicate test, but whatever. Invalid puzzle strings fail the solver. So here I added a 1 here so that it's invalid. And then we return the expected solution for an incomplete puzzle. So yeah, another kind of the same kind of test. Next up, we have the functional tests, which are actual API requests. And this right here is about 200 lines long. I did the same thing with the other one, made a valid puzzle. First, I solve a puzzle with a valid puzzle string at /API/solve, and I assert that the solution equals the complete puzzle. I solve with a missing puzzle string. So here I send nothing, make sure what's sent back is an error of required field missing. Res.body.error, required field missing. Check with invalid characters. Here I have an H in here. Invalid characters in puzzle. Solve with incorrect length. This one I added or subtracted a dot or 2. And it says expected puzzle to be 81 characters long. Next up, solve a puzzle that can't be solved. Here I added the 1 in here again. Puzzle cannot be solved. Check out puzzle placement with all fields to /API/check. Here, coordinate A2, value 3. Make sure that it's valid as true. Check with a single placement conflict. So here there's a conflict for the value 8 in A2, and that is 1 in length. Check with multiple conflicts. 6 has 2 conflicts. Check that there's all conflicts, so 2 can't go in that because there's a 2 in the region, row, and column. Check a puzzle placement with missing required fields. So here we're missing the coordinate, and it says required fields missing. Check a puzzle placement with invalid characters. Here, this puzzle has an H in it, so invalid characters in puzzle to API/check. Check it has incorrect length to API/check. There's also an H in here, but it also has invalid length. Expect a puzzle to be 81 characters long. Check a puzzle placement with invalid placement coordinate. So here I did L2, and L is not a valid coordinate. Invalid coordinate. Check a puzzle placement with invalid placement value. Here I did value of G, and it says invalid value. So those are all the tests we needed to do. If I save this, I also have to change inside of my sample env, this node env equals test. So actually I need to make a .env file quick and copy that over. And then we need to do node env equals test and save it. And I also have to restart this. So npm run start again, and it should run our tests. And actually it looks like it missed some of these. Looks like all of our functional tests pass, but none of our unit tests pass for some reason. Let's take a look at our unit tests. It's probably because I'm not importing my solver. Or yeah, I did let solver, but it doesn't equal anything. So I have to do let solver equals new solver as a constructor. And now let's save it, and it will run the tests again. Now it says 24 passing and 2 failing. The first 2 are failing, it looks like. Logic handles a puzzle string with invalid characters and handles a puzzle string that is not 81 characters in length. Oh, okay, so that's why I have to go into my Sudoku solver, down inside my solve function. I don't check those because I don't think I have to check it again once I check it in my API route, but they want us to check it again for our unit test, which really isn't very difficult. We just have to copy a couple lines from our API file, check that it's 81 characters in length, and we check that there's no invalid characters inside of it. So now those 2 should pass. And it looks like we have all 26 are passing, and we should be able to complete the FreeCodeCamp project. So now we're inside of here, we have our solution link, complete it, and we can move on. So there we go. Submit, go to the next challenge. Next up, we have the American British translator, where we can go in here and we can translate a British sentence. So if I did color and translated that, it changes up the spelling to color. If I did favorite, so that's how we spell it in America, translate it, they spell it with a U. That's what we're going to be building in the next project, in my next episode. So yeah, don't feel bad if you copy code from some other people. I mean, it's out there, so you might as well use it. I copy code all the time off of Stack Overflow. This was a very useful algorithm for what I was trying to do. Java's pretty similar to JavaScript, so it wasn't too bad to switch over to using JavaScript. And it made it work perfectly, so it's pretty cool. And I'll see you later. Thanks for watching. Subscribe, comment down below, like the video, and I'll see you in the next video.